Hi students, once again I welcome you all to my channel Abrar Sir classes. Today we will be seeing some important problems on the chapter rotational motion. This is part 11 of the video. Kindly visit the previous videos also so that you can understand the problems on rotational motion. Today we will be doing some important problems, okay, based on law of conservation of angular momentum. Now this is the first problem. A thin circular ring of mass m and radius r is rotating about its axis with a constant angular velocity omega. Okay. We have one ring, a ring, circular ring of mass m and radius r. Okay. This is rotating about its axis with a constant angular velocity omega. Right. Now, four objects each of mass m are kept gently. Now, four gently to the opposite ends of two perpendicular diameters of the ring. Okay. Again, I will draw this diagram. This is omega 2 I will take. This is omega 1 I will take. Now, how many objects? Four objects. Okay. 1, 2, 4 objects. Each of mass m. M, 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 M. Okay. It is kept here. Okay. 1 m here, 1 m here, 1 m here, and now what they are asking, the angular velocity of the ring will be the angular velocity they are asking. Now here, as the masses as the masses are kept gently, are kept gently, no external torque is applied on the system, okay. It is clearly given that these four objects or four masses, okay, are kept gently, so no external torque is applied on the system. Therefore, angular momentum is what? Conserved. That is I omega is equal to conserved. It is conserved. What is the relation? What is meant by torque? I'll just explain the concept here. Torque is what? Torque is rate of change of torque is rate of change of angular momentum. That is tau is equal to what? dl by dt. That is equal to 0. Torque is 0. Therefore, L is what? Constant, or L is conserved. L is what? Conserved or constant. L is conserved, I can write. Okay. If L is conserved, what is the formula for L? That is I omega is conserved, constant, okay, conserved or constant I can write. And what is L? MVR is also constant. Hope you understood this concept. If torque is what? Rate of change of angular momentum. Tau is equal to dl by dt. If torque is equal to 0, okay, if torque is equal to 0, tau is equal to dl by dt is equal to 0. What is differentiation of a constant? Differentiation of a constant is 0. So L is constant, angular momentum is constant. What is the formula for L? Angular momentum, I omega, and R we can write MVR. These two are constant. Now here L is equal to what? I omega is equal to considered here because there is no extra term. Now I can write the formula Li is equal to Lf. Okay. Initial angular momentum is equal to final angular momentum because L is conserved. Now what is the formula? I1 omega 1 is equal to I2 omega 2. Now what is the formula for I1? For a ring, we know that m into r square. M into r square omega. Okay. Omega 1 is equal to omega they have given. Omega 1 is equal to what? They have given omega. Omega 2 you have to calculate. You have to calculate what? Omega 2 is equal to question mark. Omega 1 is equal to, that is equal to, what is I2? I2 here, moment of inertia of the ring is what? M r square plus how many masses are kept? 4 masses are kept. Okay. What is the moment of inertia of a point mass? That is m r square. Correct? No, m r square. M r square. Like this, how many masses are kept? 4 masses are kept. Therefore, I can write this as 4 m r square. Okay. R square in place of this is I can write this as what? 4 m r square. 4 m r square. Hope you understood. Now you are supposed to calculate into what? Into omega 2. From here you have to simplify for omega 2. Omega 2 is equal to what? I can write m r square omega divided by, I can take r square as common, r square m plus of 4m. Okay, r square gets cancelled. That is equal to m omega divided by m plus of 4m. Hope you understood. Okay, omega 2 is how much? Omega 2 is equal to m omega divided by m plus 4m. This is the final answer. Hope you understood. I1 Li is equal to Lf because angular momentum is conserved. I1 omega 1 is equal to I2 omega 2. What is I1? I1 is nothing but moment of inertia of only ring here, of only ring in the first case, in the initial case. Okay, this is initial. This is initial angular momentum. At that time only mr square omega is there. That is equal to what is Lf? Lf is final angular momentum. Okay, initial angular momentum. I2, what is I2? I2 is what? Moment of inertia of the ring, that is mr square plus of moment of inertia of these 4 masses. That is, we know that for a point mass I is equal to what? M r square. In place of m, okay, this is the total mass. Okay, total mass is how much? 4m into r square in general. Okay, in place of r, what is given? I is equal to here 4m r square. Understood? Now that I am writing here 4m r square into omega 2. From here you can simplify for omega 2 to get the answer. Hope you understood this problem. Is very, very important for examination point of view. We will see the next problem. See the next problem. A thin circular ring of mass m and radius r is rotating about its axis with a constant angular velocity omega. 2 objects. Earlier how many objects were there? 4 objects. Here 2 objects each of mass m are attached gently to the opposite ends of 2 perpendicular diameters of the ring. The angular velocity of the ring is, how much will you get? Here how much we got? Omega 2 is equal to m omega. Omega 2 is equal to m into omega divided by m plus of, how much we got? For 4 objects. For 4 objects we got 4. For 2 objects we will be getting how much? For 2 objects you'll be getting 4 m for 4 objects, 2m for 2 objects. Hope you have understood. Okay, this is the formula. You can just remember like this: omega 2 is equal to m omega divided by m plus of what? N into m, where n is what? Number of objects. Number of objects. Okay. Here n is equal to how much? 2. Therefore this is right. M omega divided by m plus of 2m is the right answer. Hope you understood. We will see the next problem. In this problem, it is saying a particle of mass m is moving horizontally at speed v. Okay, this is a point mass. Okay, v perpendicular to a uniform rod of length d. Okay, and mass m, capital M is equal to how much? 6m they have given. Okay, the rod is hinged at center O. This is hinged. Okay, this is hinged. Center O, and can freely rotate in horizontal plane about a fixed vertical axis passing through the center. Passing through its center. The hinge is frictionless. Okay, hinge is frictionless. The particle strikes and sticks to the end of the rod. The angular speed of the system just after the collision. If this is d, this will be how much? This will be d by 2. This will be d by 2. Right. This will be d by 2. Now, here what is happening? By conservation of angular momentum, about hinge. Where is the hinge? Hinge is here, point O. Okay. Now L is equal to what? L is conserved. By conservation of angular momentum, about hinge body, it is conserved. You can write Li is equal to L. Initial. What is initial angular momentum of this point mass m? I can write L is equal to what? There are two formulas for L. L is equal to what? mv. R also. R is the radius. Okay. And what is this? For the time being here, this is acting as a radius. R is equal to d by 2. Okay. L is equal to mv r. Okay. R is equal to, that is equal to d by 2. L is equal to I into omega. Okay. This for a point mass, I can write m into v into this. Okay. This total length is d. This is r is how much? D by 2. Right. That is equal to I into omega. Now what is I? I is given by how much here? I is equal to, after this point mass m comes and sticks here. Okay, sticks here. This will start rotate like this. Okay, omega. Omega final. Angular speed of the system just after collision. Not to calculate. Okay, omega. Right. Now that is equal to, once if this mass comes and sticks here, what will be the moment of inertia? What is the moment of inertia of this rod? There is nothing but at the center. At the center we know. Okay, what is the center of mass for a rod of length L and mass m? In general, at the center, that is given by I is equal to how much? 1 by 12 m L square. Okay, in the same way here, 1 by 12 m. What is the length they have given? D is equal to what? L. That is the length they have given. That is L. That is d square, small d square. I can write 1 by 12 md square plus of this m. What is the moment of inertia? I is equal to mr square. Mr square for a point mass. M into r is how much? R is d by 2 the whole square, that is d square by 4, d square by 4. Now just substitute here in this equation. We are going to get mv d by 2 I into omega. Okay, I is how much? 1 by 12 m d square plus of m d square by 4 into omega. You have to calculate, right? But they have given m is equal to what? 6m. Just substitute here. mv d by 2, that is equal to 1 by 12 6 m. Okay. Capital M is equal to 6m d square plus of m d square by 4. So this I can simplify to 1 by 2 mv d by 2 is equal to 1 by 2 md square plus 1 by 4 is 3 by 4 md square. 3 by 4 md square. Right. Then this m gets cancelled. This d and this power will become 1. You are supposed to find out what? Omega. That is into omega is always here. Into omega. Into omega is here. So omega will be equal to how much? This I can write 2 times. Okay, I can divide this. Therefore omega is equal to how much we are going to get? 2 into v. After cross multiplication, 2 into by d is remaining. Right? Omega is equal to 2v by d. 2v by, again 3 is also there. 3d. 2v by 3d. 2v by 3d is the right answer. Hope you understood this. This is based on what? Law of conservation of angular momentum. By conservation of angular momentum, you would hinge. Okay. So L is conserved. Li is equal to Lf. Li is equal to what? This is the initial angular momentum of this point mass m. Okay, that is mv r. Okay, in place of r I am writing what? D by 2. Hope you understood. Is equal to I into omega. I is written separately. That is moment of inertia of the rod. How much? That is at the center 1 by 12 ml square. This is okay, 1 by 12 ml square. 1 by 12 m d square. D is what? Length. D is equal to length here. Okay, 1 by 12 m d square plus of what is the moment of inertia of this point mass m. Okay, that is I is equal to m r square. What is r? D by 2 the whole square. That is d square by 4. Add up these two. Let's substitute. Get the answer. Okay, you have to be careful while solving these kind of problems. Okay, the answer is 2v by 3d is the right answer. Hope you have understood this. We'll go to the next problem. Now it is saying a ball of mass 0.1 kg rotates in a horizontal circle of radius 1 meter. Okay, it is 1 meter at a constant speed of 2 meters per second. I will write the top view of this one so that you can understand very clearly. This is a ball of mass 0.1 kg. Okay, mass is how much? 0.1 kg is given. M is equal to 1. And what is the speed? What is the speed? V1 is equal to how much? 2 meters per second. Okay, 2 meters per second. R1 is equal to how much? R1 is equal to 1 meter. R1 is equal to 1 meter. Right. Now, second, the ball is attached to a string which passes through a hole in the, okay, hole is there here, the table. By pulling the string at lower end, the radius of the path is reduced. Okay, here the radius is getting reduced to how much? 0.5. But mass is same. How much? Mass is 0.1 kg. Now this, call this, let me call this as V2. Okay, and then how much is R2 is equal to? R2 is shrink to, got reduced to how much? 0.5 meter. 0.5. Now there is a tension in the string. This is the initial tension and this is the final tension T2. Okay, Everything initial I've written V1, R1, T1, V2, R2, T2. Now, since here what is happening? Since tension is what? Radial. See, tension is what? Radial. So torque is equal to what? What is the torque? Radial torque. It is equal to 0. Therefore, angular momentum is what? Conserved. Therefore, what? What is L? mvr is equal to, there is also constant. Okay. Here in both the cases, m is constant. I can write Vr is equal to constant. Okay, Vr is equal to constant. So I can write what? V1 R1 is equal to what? V2 R2. From here I can calculate what? V2. V2 is equal to what? V1 R1 divided by R2. How much is V1 they have given? V1 is equal to 2 they have given. Okay, 2 into R1 is how much? 1 divided by R2 is 0.5. 0.5 I can write 1 by 2, that is equal to 4 meters per second. Okay. If the radius is shrinked, V2 will be more here. Okay, V2 is how much? 4 meters per second. Let us see the answers. Okay, V2 is 4 meters per second. New velocity of the ball is, no, 2 meters from new, it will not be same. Okay, it will increase to what? 4 meters per second. No, this is also wrong. Final tension, you have to calculate tension also. What is the formula to calculate tension? Tension is what? Nothing but centripetal force. T1 is equal to what? M V1 square by R1, and T2 is equal to what? M V2 square by R2. Okay. Let us calculate M. M is how much? 0.1 is given. V1 we have been given. V1 is how much? 2 the whole square divided by R1 was how much? Same. R1 is 1. Right. That is equal to 0.4 into 0.1 is 0.4 Newton. Okay. How much is this? Is initial tension. Initial tension. Let us calculate final tension. T2 is equal to M is 0.1. V2 just now we got 4 the whole square. R2 is how much? R2 is shrink to what? 0.5. That is equal to, so 16.1 into 16 divided by 1 by 2. 1 by 2 is how much? 0.1 into 16 into 2. That is equal to how much? 3.2 newtons. Okay, 3.2 newtons is the right answer. That is final tension. This is what? Final tension. Hope you understood. Final tension is how much? 3.2 newtons. Students, hope you understood these 4 problems. First 2 problems are alike. Second, okay, third and fourth problem are different. Kindly practice these kind of problems so that you can understand the concept very clearly. Just we are using what? Law of conservation of angular momentum. If torque is equal to 0, angular momentum is what? Constant. It is conserved. You can use the formula L is equal to mvr also or I omega also based on the situation. Okay. If you like this video, kindly share with your friends. Do not forget to subscribe for our channel. Ask doubts in the comment box. Like the video if you are really liked it, so that I get motivated, and in the future also, inshallah, I will try to put lot of interesting sums for your KCET, NEET and IIT JEE examinations. Keep studying, get motivated. Thanks for watching my video.